Okay, I'm going to let you work on inverse transforming. Okay, ponder that, see what you can come up with for next time, and we'll see how it works. There are several errors that, not unexpectedly, I made in setting this up. And being careless, not having worked this out in advance. So let's just see where the errors were, okay? First place, I said we have a surge, V surge delta T, okay? That's not what we want. We want V surge lasting delta T, okay? And we accomplish the V surge lasting delta T by multiplying this blue function, the h of t minus capital T plus delta T minus h of t minus capital T, okay? This blue function, we multiply that by V surge and we get the voltage surge. We don't multiply it by V surge delta T. Delta T is built into this function, okay? So I did a V surge delta T because I knew I wanted to go to an impulse of V surge delta T, but you know, that's, well, for short delta T, you get a V surge delta T at T equals capital T has the equivalent of this. You just have an infinite spike for an infinitely short time that's equivalent to this h, this difference of the two h functions, okay? Also, in writing down the h function, I wrote h of capital T plus delta T, which, it's, think about it, the h function, h of t, is 0 up to 0, and then it goes up to 1, right?
Right.
Okay, well, to get a function that goes up to 1 at t plus delta t, I've got to translate that t plus delta t in this direction. And it's got to be t minus the quantity t plus delta t. And I won't admit in front of my pre-calculus class that I actually did that, but I did, okay? Again, just writing it down because I was moving on to something else, okay? So that was careless. And then, of course, the h of t minus capital T, that's what it would be, not h of capital T. Okay, so when I wrote it down here and I persisted in writing it down wrong, well, I've corrected these expressions to do the t minus, right? Again, it's obvious why you do that. You want to think it through and understand it well enough, and understand yourself well enough to know how clearly you've got to think about this, okay? So anyhow, we have this, okay? So we have this set of equations, and these are corrected from what we had before. So this is just your EMF function modified by surges, equal surges, at the t at 2t at so forth up to nt. Okay, then if we do the first surge only, well, same thing. It's going to be t minus the quantity t plus delta t, t minus capital T. Okay, and then we have the Laplace transforms of those expressions, and those Laplace transforms are easily seen to be this and this. Okay? Now, none of the rest of the equation is affected by that, but that is. Okay? So when we get down here, that's what we have as the thing that's multiplied by V surge over L. Okay? Now, you notice that we can factor out e to the negative s capital T from both of these. So we're going to have e to the s, well, e to the s capital T times what? E to the negative s delta T minus 1, right? And the other thing I'll say is that e to a small quantity just by Taylor expansion, you can see why that is. If delta x is a small quantity, e to the delta x minus 1 is approximately equal to delta x. That's because Taylor expansion for e to the delta x is 1 plus delta x quantity squared over 2 factorial dot dot dot, right? So that this term here just becomes a negative s delta t. Well, when this term becomes a negative s delta t, well, the s divides this s, and you get a delta t. So you just get e to the negative st delta t. And the limit as delta t goes to 0. Well, what did you get over here? E to the negative st times delta t.
Right.
Right?
Right.
Okay? So that pretty much reconciles everything. I apologize for the careless errors. But we still see the sweep of this problem. And now we see that in the limit as delta t approaches 0, the difference of the two h functions goes to the delta function, which is one of my big points. Okay? That and the fact that we can model this system. So now, for homework, work on the inverse transform.
Of both of them? Or just that one?
Well, yeah, I do them both. And so that way you'll really see, and then reflect on how the delta function is a limit of the difference of two Heaviside functions.
Okay.
Okay?